Good afternoon, everyone. We're going to do this in English, okay? And welcome to our panel. Steel builds our cities, energy systems, and our future. Yet the path ahead is far from simple. Demand is uneven. Prices are under pressure. Costs and taxes change. Supply chains remain fragile. Logistics costs squeeze our margins, and financing gets tighter. At the same time, the sustainability bar is rising. Customers ask for low-carbon steel. Regulators set tougher standards. Energy must be cleaner, more reliable, and resources must be used and reused with care. We are asked to decarbonize while staying competitive, to modernize while keeping people safe, and to invest when risks feel really high. Meanwhile, our workforce is changing. We need to attract talent, upskill teams, and protect operations against cyber threats. The expectations for transparency from investors, society, partners, they're growing. Digitalization and automation are not ends in themselves. They're tools to see earlier, decide faster, and run more stably, so we can navigate uncertainty, lift productivity, and cut emissions without guessing. The real question is whether we will use them with focus and speed, or let the wave set our course. Latin America has the talent, the ambition, and the market to lead. Let's use technology as an enabler for competitiveness and sustainability, and set the pace for the next decade. And here's how. So, for starters, for all panelists, could you share with us the key areas where your organizations are currently focusing their innovation efforts to drive transformation in the industry?
Well, first of all, welcome everyone. I hope you enjoyed the lunch, and thanks Alessero for having me here on this stage. Much appreciated. Well, as an initial statement on a high level, I would say what keeps us awake at night, basically three things. The first is the green transition along all the different phases, starting with the optimization phase that is ongoing into the transition phase, and finally the green steel phase. This is accompanied with the second pillar, that's a digital transformation. All about data intelligence, digital assistance, embedded artificial intelligence, and finally stepwise move towards autonomous plant operation. So these two things together are called the twin transition. And the twin transition has a strong interdependence with the society and the humans at the end, and it's going to change how we work, how we interact with all our environment. So that brings us to the third pillar, and that's what Danielle was mentioning about the skills gap. So we see new technologies, we see new pathways, and our industry is not known to be the most attractive one for young talents, as our business is still dirty and dangerous. So we require tools definitely to attract the new talents and to allow for the operation of the new technologies. Thank you.
Good afternoon, everybody. I'm Alberto Voltolina, and I'm Business Development Director for Russula, and I hope that everybody will be enjoying what we will be discussing today. A few words about our company. Russula is a family-owned Spain-based company, competing in the market alongside with the major well-known OEMs for plant making, for steel industry, and water treatment solutions. We are a boutique company, actively in the market since 1980s, with a proven track record of hundreds of projects. Russula Corporation comprises three different companies: Russula Engineering, which supply turnkey solution, mechanical and automation upgrades, operational guidance, and role path design support. Then we have a spin-off company, which is called SBITE, which supply AI and digital solution for not only for the steel industry, but for any other industry. And last but not least, the new venture, Hydrogen Steel, which will be a steel making facility, the first flat green mill facility in Spain. Back to your question, Danielle. innovation, the word innovation stands side by side with the word sustainability in Russula. And sustainability in the widest sense of the word, meaning people sustainability, cost sustainability, and environmental sustainability. And those are the three areas where we have focused the most in the most recent years in Russula when we talk about innovation. Before giving the words to the other, I want to extend to all of you a question, which is a common question that we have internally in Russula. Is it possible to reimagine the steel industry with the advanced technology in order to attract, train, and retain the youngest generation? In Russula, we think so, and we are taking action accordingly.
Great. Alex?
Enabling circular innovation as a cornerstone for the global well-being. This is the purpose of Metaluck, the company that I represent. And when we think about global well-being, we think about operating within the ecological capacity limits of this planet that we live in. And today we have crossed 6 out of 9 of these ecological capacity limits. Our company focus on circular innovation, and the use of AI is fundamental to the global well-being. We have been investing lately in Yunnan University. I know that a lot of you was talking about China as an enemy for the steel industry, but also we see it otherwise. So we are piloting a new technology to recycle electric arc furnace dust using ammonia leaching and launching the commercial scale next year in Malaysia. And we hope after that we can compact this technology to install it at the steel plant itself to generate revenue for the steel industry and convert this waste, electric arc furnace dust, to a money-generating revenue for the companies, and also attain the circularity targets. And the other thing is a new technology we are working on called Pulse through our technology venture builder investment arm. And that is a virtual or a digital CEO. So I might be the first guy who would be fired by an AI agent. And it's a technology that integrates with all data sources in the company with different AI agent that will assist middle management and back office where we see a big ROI, and this is where our specialty is. We are excited about that. We are piloting that already in Metaluck, and looking forward to see how this roll out next year.
Okay.
Thank you.
Hello, guys. I'm Tiago Santos. I'm AI and Data Director of Accenture here for the region. And, well, Accenture is almost plus 700,000 employees company in the world. So, first of all, we are transforming ourselves. So that's the first thing that we're doing. And when we're talking about how we are delivering that to the industries right now, we're talking about reinvention more than anything. So it's not about just getting the process that we already have and putting AI on that and trying to make it faster or try to make it automate. It's not about that. So our business is to reinvent. So look for the places where we have the most efficiency with AI. Where are the big bubbles that we can really go and work with that? And in that, we are working in agentic and scale business. So we are working with AI for scale and for risk. That's most of what we're doing. So where do we have scale that we can reproduce, where we can use agentic structure agents to really work, not just in the CEO, but in every level that we can work in the organizations, and at the same time, where we can have the most efficiency of that. So if we're talking about an industry like the steel, it's not about how we put an agent to, I don't know, supporting or call center. It's about how we can really work with agents to have the best truck routes or moments to deliver each one of the materials that we need. So working in the supply chain, working in every step where we can really have efficiency. So Accenture right now is working mostly on that, using agents, and we have AI Refinery. That's our main product right now, where we have more than 1,000 different agents already created for more than 21 different industries in the world. And we are trying to leverage how we can use knowledge and information that we have in different places in the world for all of the industries.
Oh, great. Alexander, Primetals is playing a key role helping steel producers navigate the transition towards greener and more efficient operations. Could you share with us some examples of how your technologies are supporting this transformation?
Yeah, well, I already mentioned the transition of the steel industry is a marathon. And, well, one phase is the transitioning phase. So we see many of our customers around the globe that are entering or have entered in the transition phase. What does it mean? They are operating a traditional integrated steel mill and blow down one of the blast furnaces, implement high-powered electric arc furnace with a flexible feedstock. So first of all, you need an appropriate, reliable EAF technology. So like just to mention our Ultimate series and our Quantum series, we're developing now, combining both advantages of the two technologies, a third series that allow for continuous charging to the furnace as well. Well, what is the challenge if you implement an electric arc furnace in an integrated steel mill? It's basically that you have then to decide which of the steel grades you are going to produce on which route. And you have to maintain the production schedule first, and you have to maintain the quality of your steel products for your clients. Well, and that comes in where we have recently developed the central operation cockpit. That's a single man-operated pulpit for a complete plant operation. And this is simply to support and facilitate the operator in the decision-making along the whole production chain. It's a process-related event detection system. So you get only the information on the screens where action is required immediately. And if there are multiple actions required, they're going to be prioritized. What are the most important actions to be taken? So it really brings it down to the operator to support him. And again, going back what I said, that's the skill gap. The same system can be used offline for training purposes of new recruiters, but also for emergency cases training, like a flight simulator in an aircraft. And it supports and facilitates also speedy startup and commissioning at the end, and any software upgrade. So that's one important development. Another one, as I heard also about circularity, I think that's a fantastic example. So what really thrives us is scrap upcycling. So we have the issue that scrap is continuously deteriorating in the quality, and we are going to high-end steel grades. So we have to upcycle the scrap, and for this we need, again, digitalization, AI assistance, and mechanical systems as well to separate it from the tramp elements. Treatment of dust slags, another example where we pretty much engaged supporting our customers. And the last thing I'd like to mention in the transition phase is about the system called the TPO, through process optimization. That's also an important system. So it starts basically from the final steel grade that you want to produce there. So this comes with certain properties, and it starts with the feedstock material. So you get thousands of parameters. So we have so many sensors in there. And now it's all about to arrive there to see is there any deviation in the recipe how to produce a specific steel grade, to evaluate it, to bring it to the attention of the operator, and to propose or recommend any action to be taken to bring the production back on track for the finalized steel grade. If this is not possible because the deviation is too big, it does an automatic downgrading of the steel grade for the next best customer order. So I think that's really important. This system is growing and will support in this transitioning phase quite significantly. Thank you.
Alberto, Russula has been pioneering digital solutions to making rolling mills safer, smarter, and more efficient. How do technologies contribute to reducing emissions, optimizing operations, and even helping attract and retain new talent in industry?
Well, first of all, I owe you a brief explanation of what we mentioned before, the breakdown of sustainability that I previously mentioned. So, people sustainability meaning fostering interesting working condition and taking care of health and people of the team. Cost sustainability meaning proposing operational excellence, reducing waste, thus decreasing dramatically, hopefully, the transformation cost. And last but not least, environmental sustainability, meaning reducing the carbon footprint, the ecological footprint, avoiding wastes, and thus making our industry as eco-friendly as possible. So I will give you a few examples on people sustainability and then on cost sustainability. The first one about people sustainability, I can say that in Russula, driven by our historical know-how, in the most recent years, we have spent a lot of effort in developing what we call the safe and autonomous mill. This initiative aims to enhance the safety in the mill in introducing a new level of automation inside the rolling mill. In order to accomplish that, a new level of sensors and advanced analytics have been developed. This increased safety, as we said before, but not only. It increases also process reliability, process repeatability, and is benefiting the overall mill performances. A good example applicable to this kind of people sustainability can be what we have done for Nucor Jewett, our customer in Texas. Nucor Jewett is a mill in Texas, United States, where we implemented a new patented boosted series of sensors strategically positioned all around the mill, thus enabling each sensor to detect the most important variables that we have involved in the rolling process, meaning tension control, shear cutting, speed, all these kind of parameters. And then an advanced camera system detects cobble, thus making the rolling process smoother and safer without human intervention. On the top of it, on the top of this kind of level 0, level 1, we have what we call the Mill Pulse, our plant management system, level 2. We put into connection the workshop and the production floor with the operation management, thus giving a full visibility of the most important variables, such as production KPIs and all these kind of important parameters. On the top of it, like a pyramid, we have what we call the digital operator, the real AI know-how. There is this kind of like a digital operator which is capable to collect data, analyze data, and take decision on the data that he analyzed. This digital operator stands side by side with a human operator, helping the operator in taking decision and modifying eventually any mistake that the human operator can do. So you can easily understand that this is a kind of solution that increases safety in the mill, hopefully with zero accident, and minimizing the human interpretation of the data. Now I want to give you some important example for what concerns sustainability in terms of costs. Two examples. The first one in Chile with our customer ASA. In this plant, we have implemented an advanced camera solution in combination with some AI-driven solution. And this combination is capable to increase a lot the cutting performances. So the solution can save in metallic losses up to 2,600 tons per year, which is a significant save for a mill that is producing 500,000 tons per year. Another example can be Chesa, Spain, a mill in Europe, where we were able to implement a system that coordinates the changeover activities in between the roll shop and the production floor. Through this, we were able to decrease the downtime up to 10%, with an estimated saving of approximately 2.5–3 million per year. So all those applications are very important. I would say also in terms of getting rid of redundant Excel file that we usually utilize in our steel industry. We invested a lot on those applications, Danielle. We think that that's the future. That's a good way to enhance human retention processes, also Alex was previously mentioning. And those solutions have a big impact on cost sustainability and people sustainability for our customer. Mm-hmm. So I go back to my previous question that extend to everybody. We do think here, Russula, that we can transform the steel industry through advanced technologies in order to attract, train, and retain the youngest generation. Just to give you some final numbers. Gen Z will make up to 30% of workers globally in 2030, and this number will be increased up to 40% in 2040. So that's an important number, and we all know how Gen Z is. They born digital, they speak digital, so I would say that our industry has to cope with their pace, and we think that advanced analytic solutions are the only way to give a reply and a transformation to our industry.
Oh, perfect. Tiago, from your vantage point, how would you characterize the current landscape of enterprise AI adoption?
Well, that's a big question, and at the same time connecting with what was just said. Probably in 5 years, we'll have employees that never wrote a single email in their life. In 10 years, we'll have employees that never wrote or never read a single book in their entire life till the end. So the landscape is that right now we have to adapt. We don't have that option anymore. So we have passed the moment of experimentation, and now we are in the moment of industrialization. But the next step will be transformation. We have to transform all the process that we have. It's not an option. Basically, they will be ready, they will come ready, and we are the ones that will have to adapt. So our companies will have to adapt to these new employees, to this new process. It's not just about how we take care of our customers, but how we'll take care of the people that we'll have. So the landscape that we have right now is that the costs for AI are reducing and will be reducing in the next years drastically. At the same time, right now, those costs are really, really close to the human costs that we have for most of the operations. But this will change, and it's changing rapidly through all over the world. So we have to not make a lift and shift of the process that we have, but reinvent the process that we have. Make an AI reinvention. In Accenture, we call it air. So because it will be like the air that we breathe. So it's an AI reinvention that we have to do for each one of the process. The important thing is that if we are talking previously about how we put this landscape of AI and the companies that we have, of course we have the adopters, the ones, the early adopters that will go in front. So the ones that are mostly talking about experience and the customers and all of that. But the big points will be in the industry. So where we are in the steel industry, those will be the big changes. So when we start to reinvent and reshape and rethink our process with the AI, so it's not a process that we adapted, but the AI process since the beginning, that's where we're starting to find the big numbers. So right now, what we have in the landscape is that we have the adopters, mainly companies that are creating the big agents and agentics that we can leverage. Then we have the landscape of the industry, so where we are putting the big inventors, so Google, Amazon, Accenture, so NVIDIA. So we are doing this in a scale that can really go to most of the big companies, the 500 fortunes. And after that, we'll go to the middle, to the small and medium business. So we will have this big process that we are creating for the big companies as you guys are, will go cheaper and cheaper and cheaper, and it will go for the whole industry. So the big thing here is to understand what is a commodity and what's not. So technology is kind of a commodity, but that's not the really important thing. It's how we are going to use it. So the differentiation will be in the process. The differentiation will be in how we understand what really is human and what is not. So I believe that this is the main landscape that we have for the next years.
Oh, great. Alex, what is the role of circular innovation in increasing revenue and lowering costs for the steel industry?
From our perspective, and because we focus on circular innovation, our main clients are by nature electric arc furnace producers. And we try to identify companies that are bringing innovation in the space to invest in these companies. They are innovative startups sometimes, and then how to scale the adoption of their technology. So when it comes to that, I like to mention a few of these technologies, which we have an eye on, and we did some partnership with. Green iron in Sweden, and having a small furnace, 5 tons an hour, that use hydrogen or green hydrogen to reduce iron oxide and other metal oxide wastes. We see good application for that, especially in electric arc furnace producers, and the future, hopefully when also green hydrogen becomes more cost effective. That's one. On the AI part, Varit in Germany, being focused on different use cases, whether on maintenance, planning, energy, or quality, and more of a taking an ROI approach to that. And also, as Alexander mentioned, on the scrap, upcycling scrap, I think there's a lot of focus here on the ability to use AI and machine learning to be able to increase the yield and the scrap mix. Tomra is one of the technologies, but also some others in the field. And I like always to mention what Swiss Steel is doing. And even though I'm not paid by Swiss Steel to market what they do, but whether their UGI furnace, recycling batteries, household batteries, and catalysts to produce ferroalloys using plastic for slag foaming, using, for example, aluminum scrap for deoxidization, and other type of circular innovation. For example, the zinc enrichment to put back the electric arc furnace again in the loop of the furnace and increasing the zinc. So we see some of these are interesting to generate more revenue. And I like to talk more about generating more revenue than just reducing cost, because our focus is developing nations, Latam and Africa, and Southeast Asia. So with that, I think circular innovation, aside from the importance of sustainability, but provide a good pathway forward.
Okay. Alexander, Primetals has been advancing innovative technologies to make steel production more sustainable and efficient, green steel. Could you share some key solutions you've been working on and how they are being applied?
Well, I would say that till now, this was the warm-up. Yeah? Now are really the incredible things, and I have to take now a little bit of breath, otherwise I get too overwhelmed. But these are really the game-changing technologies I'm now going to talk about. So it's about electrification. So the steel industry's only way forward is finally the electrification. And at the same time, it's a challenge, yeah? Because unfortunately, energy is limited. Renewable energy is still not accessible at scale at any place, and it's expensive. So that's the challenge around the electrification. So well, let me talk first of all about RVD ESP as first technology, a game-changing technology that is fully electrified. Continuous casting and rolling, avoiding again reheating of the slabs in a fossil-fired reheating furnace, very compact, coming only with scope 2 emissions, 0 scope 1 CO2 emissions. So there are now certain references out there in the world. And what is the amazing thing is really that the product portfolio is expanding. So the product is hot rolled coil, so a new product line replacing more and more from the hot rolling, cold rolling portfolio. So that saves cold rolling and the pickling operation. It's much more compact and brings the operation cost significantly down, while it just utilizes half of the energy. So I think that's the way forward for this industry. The other technology, well, let's keep on going with electrification. Electrified heating in any sense is key for this industry. We are talking about high energy intensive industry there. So well, for the time being, we are heating with fossils, mainly based on coal. So we still run 70% of all the steel runs still on coal and coke. With electrification, we can heat materials. So inductive heating of slab, like in the RVD ESP. So we are expanding now this also for much thicker slabs, building a prototype for 6 slab inductive heating instead of using reheating furnaces. Well, in the same way, we can heat gases by inductive heating, like hydrogen, or recuperative burners with the recovered gas again heated by inductive heating. Another important topic and a key innovation is a product called the active power feeder. The more electric arc furnaces we are going to use, and they are hungry for energy and not continuously use the electric power, we have always power on, power off, and that's a burden for the power grid. The more renewable energy within the power grid, the more challenging it becomes. And we have to maintain the power grid factor that is required from the power grid providers there. So what is the active power feeder? Is a multi-level modular converter based on a medium voltage technology that basically completely avoids a flicker system on the medium voltage level. And we are just under the commissioning of the first application for an electric arc furnace there. And last but not least, an important topic we have to touch upon is direct reduction technologies. So Primetals Technologies is a full liner in direct reduction technologies. So we are for more than 40 years licensee of the Midrix technology, well established, that has now moved from the traditional way of gas reforming into flexible use, hydrogen and gas, and also allow for 100% use of hydrogen when it's scaled and reasonably priced. But the key innovation, and that's the highlight at the end of what I'm going to say, is a development called HIFO, and HIFO combined with smelter technology. It's based on fine iron ore direct reduction based on hydrogen. It does not require any agglomeration step of the iron ore. That's unique, and it can take every iron ore, low-grade iron ore, medium, and high-grade iron ores for highest metallization. We are focusing on low-grade iron ores, because there is definitely oversupply, while for the high-grade iron ores we see a clear undersupply in the market with premium prices there. So then you have a lot of gangue in the DRI, and that brings you to the smelter development. So you melt the low-grade DRI there, separate the high amount of slag there, adapt the slag to be used in the cement industry, and produce hot metal or pig iron to be used in the BOF or in the EAF as a feedstock. And we just have taken an FID decision with our partners, voestalpine and Rio Tinto, in April earlier this year, and have broken the ground recently, a couple of weeks back, and establishing now in Austria, the premises of voestalpine, the first industrial scale prototype for the HIFO, including a smelter. So we can produce either DRI, HBI, hot metal or pig iron, depending what we are going to produce, prove and de-risk this technology, and hopefully roll it out to the market from 2028 onwards. Thank you.
And with water use and circularity gaining importance in sustainable steelmaking, what new technologies or approaches is Russula developing to enhance efficiency and resource recovery in water treatment plants?
Well, we can say that in the most recent years, we have been leading the digitalization and AI scalability in water industry. This statement applies not only to the steel industry, but to any other industries where we are actively working on. I would say pulp and paper, petrochemical, pharmaceutical. Our water cycle, our water portfolio, our water solution portfolio covers the entire water cycle, from inlet water, makeup water, process water, outlet effluent water, wastewater, and we have developed advanced technological solution for gray water recovery systems, such as minimal liquid discharge and zero liquid discharge systems, and last but not least, a leak water detection system. Now, this question allow me to touch the last area of sustainability that we mentioned before, environmental sustainability. And to do that, I want to think for a moment altogether about the situation in Monterrey, Nuevo León, Mexico, which is a very big industrial and urban city, which is unfortunately struggling with water. They are facing water shortages due to high demand. There is no water available. So it's an arid, semi-arid region, and the natural water resource is limited. And we have here in front of us, attending to this panel, several steel makers involved in the area. Mr. Cesar Jimenez is here in front of us, so he can tell us probably that he's like struggling with those kind of water recovery solutions. And for Russula, we have a technological reply for that. We have developed a gray water municipal water recovery system, which is equipped with a state-of-the-art zero liquid discharge system. This system allows not to utilize fresh water, but just to collect and treat the effluents, and then re-enter this water inside the process as makeup water. At the end, the waste is driven outside the process as into solid form. Another nice example talking about environmental sustainability could be the idea of thinking the water treatment plant not as a revenue source. Water treatment plant is not a revenue source, and is a facility, is an auxiliary system that is intended to not create problem in terms of maintenance and process. That's why also in this case, as we did for the rolling mill production, we have applied the so-called digital operator. The digital operator, also in this case, what we call water pools, is able to detect when the variables of the process move outside the normal parameters, and is capable to pinpoint the exact source of the instability. Another example, we had a customer that he was frequently changing and cleaning the filters. They were like overestimating this activity, and the digital operator was able to collect the data, analyze the data, and support side by side the operators to tell them that that was not the case. So this is an example that gives you the idea that those kind of technological solution and AI solution allows our industry also to reply to another problem that we have in our industry, which is the lack of expertise.
Mm-hmm. And Alex, with so much hype around AI, how can Latin American steel companies separate real financial value from experimentations, adopting a practical profit and loss anchored approach?
Well, I know that you may be skeptical about implementing AI in your company. And this is where I want to address the big elephant in the room. And you have all the right to be skeptical. Recent studies that was published by MIT that shared the result of 300 public companies, 95% of AI pilots have failed. 95%. And those who succeeded, and this was not because of the technology. And the reason for those who succeeded, because they were able to integrate AI better. And that is, you have three challenges here, or frictions. Human friction, and then you have the organizational friction, and then you have the technical friction. To be able to utilize AI in the company, you have to address these frictions. And when they arise, it's a good sign. It's a good sign to redesign the workflow, the systems, the governance, to be able to implement these AI solutions. Otherwise, it wouldn't work. And that's what's more important. So for that, I would take a very different approach. First, identifying the lever profit. What is it that you want to make here? And then go for the low-hanging fruit. Maybe that's yield, energy, and so on. Start with a pilot. If it doesn't work, kill it quickly before scaling. And don't work in silos. So meaning that you have to be able to integrate AI into your current data sources, whether ERP, production, supply chain. And that's why, from our expertise, we developed Pulse with our own proprietary machine learning that integrate with all the data sources to help optimize decision making. Because our focus was or has been on the back office. And that means reduction of working hours. We estimate that people will start working probably 25 hours a week. I mean, does that mean that you will have to fire people? It's a decision that companies will have to make. It's either that or accepting that people would start working 25 hours or 30 hours a week. So this is what we are seeing. We also see that the job of analysts will become obsolete totally. Maybe accountants and many other jobs. There's a big question even on middle management ability to continue. So exciting and not. I think it's our human adaptability, and the gap is, becoming bigger and bigger.
Yeah. And Tiago, from your experience helping large companies scale AI, what does it take to turn AI into clear, measurable business value?
I believe that there's a triple A there: architecture, alignment, and adoption. So those are the three things that we need to remember when we're talking about how to scale. So the first thing, as we were saying, is architecture. Garbage in, garbage out. So our data needs to be good. Our data needs to be useful. And of course, this architecture needs to be scalable. So I say that this is like playing with a Lego from Star Wars and 50,000 pieces with a 5-year child at your side saying, Daddy, I want to play too. So you can tell the company, wait for 1.5 years and then you have something that you can play. So you need to make it modular. You need to be scalable. You're going to start to build the POCs, the MVPs that we're saying, but they need to be connected in a single vision that will take you to the future. So what's the process that I want to make end to end, and how I'm going to start to create AI agents in each part of this process that I can reuse in other parts, that I can scale for different ways. The second thing, as we said, is alignment. It needs to be aligned to the P&L. So what's my main strategy? I want to reduce costs. I want to increase revenue. I want to increase evaluation. I want to reduce risks. Where exactly is the main goal that I have? So the POCs that I'm doing, the architecture that I'm building, the AI that I'm unleashing needs to be aligned to that. Because this is the main thing. If you do not make incentives to the company to put the AI, they will not be doing what we want. So we need to be in the same strategy that the company is going. So the data and the architecture need to be aligned to the P&L. The third thing is alignment. And adoption. And adoption is about people. So how we are going to make people use AI. If we go to the people and say, look, create this AI and then you lose your job, they won't do it. They won't use the AI that we are trying to make them do. What we need to understand is that we are not going to replace people by AI. We're going to replace people by people with AI. That's the main goal. So AI is about unleash. It's not about firing. It's about unleash creativity, unleash time, unleash people to do what people can do. Our brains are the biggest algorithm that will ever exist. You look at someone, you look at me, and you have a complete idea of who I am, what's going to do, what's the risk that we have. Our brain is much faster than our conscious part is. And the thing is that we are not measuring the human part right now. We're measuring only volume. So if we take a look at our supply chain, we know how much parts we have in the beginning, how much parts we have in the end. We don't know what the human have done in the middle of this process. And if we want to use AI there, we need to start to measure the human. And this is what will take to adoption. So we need to tell people, look, this will give you time to do what only you can do. That is being human. That's the only thing that will do. So the AAA, I believe that is the biggest thing that we have done. The companies that are realigning AI with human are the ones that are in the 5%. In this study of MIT that our friend just mentioned it, the difference is how the ones that are using just AI and the ones that are connecting AI with the human part.
Oh, very interesting that. And now, quick question for everybody. What's next in digitalization and innovation for steel mills?
Well, if I'll start again here, difficult to say, always to look into the crystal ball in the future, but I would say first of all, a little bit more political comment maybe here is, will we see a decoupling of iron making and steel making? So we have been discussing this in our industry for the last couple of years, I would say. And at the end, I had a feeling we came to the conclusion that the energy-intensive part, which takes 80% in the iron making, should move where the energy is available and cheap. But if we follow all the discussions also this morning about geopolitical tensions and tariffs, yeah, we can put in again a question mark behind. Is it wise that we really delocalize the iron making from and decouple it from the steel making? I think that's an answer we have to find. It's important for this industry because it's about competitiveness. And the second thing, as you referred to digitalization, well, I think we heard it a lot on this panel, and this is going to continue even to accelerate. There's no doubt this cannot be stopped. And well, if we just look at the last couple of years, what happened in the plant operation and maintenance, well, we have a paperless plant operation. So we did in the past all these big files about the operational manuals, maintenance manual. Now is everything digitalized. You have the QR codes on the equipment. You go there, you scan it, you connect it to your drawings, to the PIDs, flow sheets, documentation, maintenance schedule. All that happened just over the last few years. Yeah? So, well, I agree what has been said. It's going to accelerate, and likely we will see robot dogs moving around with multiple sensors equipped, and all the drones utilized for the maintenance. Exciting future ahead. Thank you.
Okay. Anyone?
Yeah, sorry. No, and this is a very good point. So having the measures along the process. So if we take a look in the next few years, let's watch how our industry is right now. If we have a truck that is stopped in waiting to transport some steel for port, how does the truck driver decide if he needs to leave now or leave in 30 minutes? What's the cost that he will have for oil and gas to be in truck or to be in the traffic or to go in the slower traffic? How's the cost that we have? How much time he will take to leave and to get there? What's the highest risk that he stays there in the port waiting to have for the ship that will come, or that is delayed, or that he did not get there in time? Right now, all these decisions are made based on volumes, based on the past, and in a batch base, if you can understand that. But basically, we take the data that we have for yesterday, and we take the decisions that we need to take it right now. These will change drastically. So in the next 5 years, probably what we'll have is that we'll have sensors that says you need to leave right now. You need to leave in 15 minutes and go for 50 miles and then stop. The truck that is right now here in Bogota needs to go to Medellin and wait there for 2 days. So this will be agentic. And this will change. Imagine how much this will change of how much carbon do we have in our industry, and how much cost do we have, and what's the revenue that we have, and what are the times that we're delivering the products to our customers. This will be the biggest change, having the micro data for the mega process.
I would reply to this question without mentioning anything about technology, but I will raise a topic that sometimes everybody underestimate, which in my opinion is very important, and is the data governance. We had a lot of excitement in the last few years about all these nice, digitalization, AI solutions, but we need to keep in mind that data is a strategical asset, corporate asset, which has the same importance of equipment, raw material, and all those nice and beautiful things that we have in our plant facility. So I would say that solid, good digitalization not only is able to collect data, but also ensure few things about the data: integrity, traceability, reliability, and security of data inside the life cycle of our plant. So I would say data governance has 3 or 4 pillars. The first one is data reliability, meaning ensure that in the decision-making process we have valuable data, solid data to take decisions. Interoperability in between platforms, business unit, suppliers, talking with the same data, everybody. The third one is regulations in terms of cybersecurity, data protection. And the third one, which is very important, is scalability, meaning that we cannot reinvent the wheel any time that we want to escalate with new digital twins, advanced analytic solution. The data model has to remain the original one. So to conclude, I would say that digitalization, the word digitalization stands along with the word data governance, meaning that the digitalization has to transform the information into available information, reusable information. That's the only way to have our plant truly smart and truly intelligent.
Alex?
Well, I know this may sound very futuristic or stretching outside the box, but my vision for electric arc furnace producers, that they will change from a commodity producer to a material and manufacturing service provider. We recently invested in a Creative 3D company in the US. Think about it as a factory in a box, decentralizing manufacturing. We see the possibility of serving oil and gas, mining with spare parts on delivery, reducing cost of inventory, lead time, producing metal powders and from scrap or from special alloy scrap, and being able to produce this raw material that is today growing 20% a year. We project that this could bring probably $20-30 million of revenue at 80, 90, 100% margin. And we even foresee that this might be a new era of having digital licensed even spare parts on need. Something very exciting, and looking forward to see what unfolds. Thank you.
Oh, great. So I took a few notes. Well, first, choose actual problems that matter, and then you define the solution, the technology to approach them. Strengthen the backbone. Start from the base. Clean, reliable data, connected equipment, modern control, strong cybersecurity, and governance. Third, build capability. Operators, engineers, and digital teams collaborating. Technology multiplies human expertise. It does not replace it. So we need to involve and integrate people with the technology. And looking ahead, add one more accelerator to this foundation, AI. It is not a magic wand. It's another tool. And on top of automation and good data, it can unlock the next wave of productivity and sustainability for our industry. And we will continue discussing this very topic at this auditorium in our next lecture. And so I invite you all to stay with us as we're going to go deeper into how AI can enable development across Latin America's steel industry, turning pilots into scale and ideas into results. Thank you all, and let's keep building what matters.